This is a beautiful, creepy, non-calculated question. Love it. The values of the functions g of x and h of x and their derivatives g dash of x and g h dash of x are provided in the table below for certain values. So they figured out these equations and they put the values in. Evaluate the derivative of g of x over h of x. Well, first of all, I just want to grab a little scrap paper here, and I want to say, that g of x and h of x there, they're a function on top of a function. It could be something like e of x over 3x squared plus 1. And if that's what you were finding the derivative of, I hope that you would use the quotient rule. And that's what you have to do here. Okay? So, in using the quotient rule, I'm going to write this out really neatly, and I'm going to say d dx of g of x over h of x. Well, let's see. That would be g dash of x times h of x minus h dash of x times g of x all over h of x squared. Okay, so that's different maybe than what you thought of when you first did this problem. Okay, at x equals 3, so I'm going to go down this lane. G dash is 4. Regular old h is 6. Minus h dash is negative 5. And g is negative 3. And h squared is 6 squared, or 36. So that gives me 24. This gives me positive 15, so minus 15 over 36 is 9 on 36, which is 1/4. Love it. Okay, the next bit of that says evaluate, sorry about that little smudge, evaluate the derivative h of g of x. What rule are you going to use here? Well, we use the quotient rule here. Now we're going to use the chain rule, because we have a function within a function. Let me give you a little example of that. Maybe our function within a function when we do problems would have been something like 2x squared plus 5 to the 5th. Right? So I have something to the 5th, then inside I have a function within a function. So how do I do that? Well, I first take the derivative of h, so let's go d dx of h of g of x. I might have put too many brackets there, I'm not sure, is going to be equal to h dash of g of x times the derivative of g of x, g dash of x. And now I'm at x equals 1, so I'm going to go in the 1 column up here, try to get everything on the paper at the same time, the 1 column, and I need g of x, well that's 3, so I need h dash of 3 times g dash of 3, well that's negative 4. H dash of 3, that's over here, h dash of 3 is negative 5, so negative 5 times negative 4 will give me 20. Love it. All right, when I look at this last one, it's really good. It says describe this. H double dash, I'm going to just write it down, h double dash of 1 equals negative 1. Describe with justification what the graph of h looks like at this point. Okay, well, let's talk about the point. So we're at x equals 1, right? And at x equals 1, h is 2. So I'm really at the point 1, 2 on h. So the first thing I'd say is that the point on h is 1, 2 on the original function. The next thing I'd say is that h dash at 1 is 0. So I'd say since h dash of 1 equals 0, 1, 2 must be a turning point or a stationary point. Forgot how to spell stationary for a minute. A stationary point. Wow, I'm way off the page there. Must be a stationary point. Then the next thing I'll say is since h double dash of 1 equals negative 1, since it's negative, that's less than 0. Therefore, concave down. So 1, 2 is a maximum. Beautiful. I like it.